Good morning, good afternoon, good evening, and thanks for tuning in to our today's presentation. In our earlier video, I had given out questions on the topic whole numbers, and I had asked the learners to be able to tackle the questions so that in our subsequent video, which is today, we can be able to look at the answers and see the possible ways that the questions were to be done. So straight away, I want us to get to question 1 so that we can be able to see the possible ways that the answer was to be found. In question number 1, what is the next number in the following sequence? The sequence that we were given was 8, 12, 18, 26, and 36. In the solution, prior information that the learner should be able to have is that a sequence is a pattern, and a pattern is a set of numbers that has got a regular formula by which anybody can be able to predict the subsequent items in that pattern. So for us to be able to find the next number in the pattern or in the sequence, we must first be able to arrange the numbers in a manner that we can be able to easily find the next number. Before that, it is also worth to mention that we have two sets of sequences or patterns. The first set of patterns is called a decreasing pattern, where the numbers decrease from the high first number to the lowest number as they progress. The second pattern is known as an incremental pattern. This is a pattern in which the numbers progress or spiral by increasing in size from the first one going to the next one. They increase up to the last number. So this way one can be able to tell that the pattern is made up of increasing numbers. So with that in mind, let us first write our pattern so that we can discover if it is incremental or decreasing. So our first item was 8, 12, 18, 26, 36. And then we were asked to find the next number in the pattern. So in the solution, and before we get to the solution, as we can see, the numbers are progressing in size, where the first number is 8, followed by 12. You can easily tell that 12 is bigger than 8, followed by 18, which is bigger than 12, then followed by 26, which is bigger than 18, and lastly 36, which is bigger than 26. This informs us that the pattern is made up of increasing numbers. So in the solution, we need to establish the pattern that was used to inform this kind of arrangement. So we need to get the difference between two items, each of the two items in the pattern. So between 8 and 12, the difference is, or rather the numbers are increasing by a +4. because 8 plus 4 gives us 12. Between 12 and 18, the number increases by a plus 6. Between 18 and 26, the number increases by a plus 8. And lastly, between 26 and 36, the number increases by 10. Looking at the differences, we have a plus 4, plus 6, plus 8, a plus 10, and from here anybody can predict that the next difference will be a difference of plus 12. To make it more easy to understand, we can break these items further and find the difference between 4 and 6, which is a plus 2. The difference between 6 and 8, which is a plus 2. And the difference between 8 and 10, which is a plus 2. And finally, between 10 and 12 is a plus 2. Now, this plus 2 clearly shows us that we have a regular kind of a pattern. So back to our solution. Now that we know the difference between the second last item that we have, 36, and the one that we are looking for is 12, all we need to do is to add 12 to 36 for us to come up with the last item or the next number in the pattern, which is 48. So in our solution, the next number in the pattern is 48. Question number 2. The question for question number 2 was 3 passenger trains are set to leave the station at intervals of 4 hours, 6 hours, and 9 hours respectively. If they all left together at 8 a.m., after how many hours shall they live together again? In a question of that kind, sometimes the examiner may want to know at what time the trains shall live together again. And in some occasions, they may ask at what time and day, if for instance they had given us the day that the trains first left together. So in our solution, the main idea here is whether the learner knows how to find the LCM of numbers. So in the level of class 8, the learner may not necessarily be asked the LCM of numbers, but this is another way of asking a learner to find the LCM of numbers. So here the numbers that we are having are 4, 6, and 9. So the LCM of these numbers can be found as follows, and this is how we find the LCM of numbers. So we get a common number that can be able to be used to divide through all the numbers, and that number must be the smallest prime number. And so the smallest prime number that we have in numbers is number 2. And try to check out if the number 2 can be able to be used in dividing any of the numbers that are lined. So we try 2, and for sure 4 divided by 2 is 2, and 6 divided by 2 is 3, but 9 cannot be divided by 2, so we leave 9 as it is. We proceed, we again try 2 because 2 divided by 2 is 1, but this time round 3 cannot be divided by 2, neither can 9 be divided by 2. So 3 and 9 will remain. Now we shall proceed on and find another prime number that can be able to divide the remaining numbers. So another prime number that we can try is 3. Of course, 1 cannot be divided by 3. But 3 divided by 3 is 1. 9 divided by 3 is 3. We have one more step. Again, we can use 3. 1 divided by 3 cannot be divided by 3. 1 divided by 3 again cannot be divided by 3, but you can divide 3 by 3 and get 1. Up to such a point where you have all the numbers that have been divided to the result of 1, 1, 1, then you can be sure you are almost getting to the point of finding the LCM. Now the next thing that you need to do is to take these numbers here. 2, you multiply it by 2, multiply by 3, multiply by 3. By so doing, 2 times 2 is 4, and 3 times 3 is 9, giving you 4 times 9 as 36. So 36 is the number. But basing our argument from the question was asking after how long will the trains live together again. And because we are dealing with hours, 4 hours, 6 hours, and 9 hours, our answer should be in hours. So the trains will live together after 36 hours. Question number 3. The question was, what is the difference between the LCM and HCF of 27, 36, and 54? Now, in this question, at least we understand what the LCM is. HCF is another name for greatest common divisor, or the GCD of numbers. So when we have a HCF, it also implies greatest common divisor. So here we are finding the LCM of 27, 36, and 54, but as well we shall find the greatest common divisor of 27, of 36, and 54. So to the solution, we start with the LCM. Then thereafter we shall be able to find the difference between the two. So LCM of 27, 36, and 54. Again, just like in number 2, we are looking for prime numbers that we can be able to use to divide any of these numbers. So we can try 2, as the smallest prime number in whole numbers. So we cannot divide 27 by 2. We can divide 36 by 2 into 18 and 54 divided by 2 into 27. Again, we can use 2, but we cannot divide 27 by 2, so it remains as it is. But we can divide 18 by 2 into 9. We cannot divide 27. We try 3. 27 divided by 3 is 9. 9 divided by 3 is 3. 27 divided by 3 is 9. We proceed, then we divide again by 3. 9 divided by 3 is 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. And lastly, 3 divided by 3 is 1. Here we shall have 1, and here we shall have 1, and we are done with finding the LCM. So the next thing we do is we multiply all these numbers. So we shall have 2 times 2 times 3 times 3 times 3, where 2 times 2 is 4. 3 times 3 times 3 is 27. 27 times 4 gives us 108. Yes, 27 times 4 gives us 108. Then to the HCF, or greatest common divisor. For greatest common divisor of 27, 36, and 54. The major difference between greatest common divisor and LCM is that with LCM, you must have to divide the numbers using the smallest prime numbers until you arrive at 111, just like we did. But with highest common factor, or the greatest common divisor, we are only concerned with that one prime number that can be able to divide through all these numbers. So 2, we can divide 36 by 2, but not 27 and 54. So we are not going to use 2, but we shall use 3, because 27 divided by 3 is 9, 36 divided by 3 is 12, 54 divided by 3 is 18. Again, we can use 3, because 9 divided by 3 is 3, 12 divided by 3 is 4, 18 divided by 3 is 6. Beyond here, we cannot use any other prime number to divide the numbers, because if we use 2, we can only divide 4. If we use 3, we can only divide 3 and 6. So beyond here, we don't have any other prime number. So our HCF remains 3 times 3, which is 9. So to the final solution, because we were supposed to get the difference between LCM and HCF, we shall have 108 as our LCM and 9 as our highest common factor. So our answer will come to 99. To question number 4. In Migori town, the total number of women and men was 56,230. The number of women and children was 24,865. If the number of children was 24,865, if the number of children was 12,650, what was the number of men in that town? So from the information that we have, the number of men and women is 56,000. Question number. The number of men is 50 and women is 56,230. The women and children is 24,865. The children alone is 12,650. Now from this information, the question that we are supposed to answer, men alone are how many? As we can see, the men are put together with women. Their number is 56,230, meaning if we would have the number of women alone, we would subtract it from men and women and we would find the number of men. When we try finding the number of women, again here we find women put together with children and their number is 24,865. Again, this complicates the whole question because here we do not know exactly how many women that we have. Finally, we have children alone. Now, this makes it much easier for us in the sense that by having the number of children, we can be able to separate the children from women and children together when they are put together, which is 24,865. And then we shall have the number of women. So with the number of women and the children, which is 24,865, we subtract the number of children, which is 12,650. So we can do this. 24,865 take away 12,650. 5, 1, this is 2, 2, and 12. So this one now forms the number of women, because the earlier one we had was women and children. And this one here, which is the same as this one, and this one here was children alone. Now that we have the number of women, we can go back and subtract that from the number of men together with women, which was 56,230. Then we subtract women, which is 12,215. If we do this, we shall come up with the number of men alone. This is now 10 take away 5, 5. We have 2 take away 1, 1. This is 2 take away 2, 0. 6 take away 2, 4. 5 take away 1, 4. So this now forms the number of men, 44,015 as the number of men. To our final question, question number 5, and the question was, the number of people who visited a game park on Monday was 65. Tuesday was 49. On Wednesday, 58. The number of people who visited on Thursday was 12, less than those who visited on Thursday. The number of people who visited on Thursday was 12, less than those who visited on Wednesday. The number of people who visited on Friday were half the number of people who visited on Saturday. A total of 354 people visited the park during the 6 days. How many people visited the park on Friday? Now to the solution. The total number of people who visited the park on Monday was 65. On Tuesday was 49. On Wednesday, the number was 58. Now from Monday to Wednesday, we have exact numbers. But on Thursday, we are told the number was 12, less than Wednesday. So meaning that on Thursday, the number is the same as that of Wednesday, only that it is 12 people less. So that logically leaves us with 58 as the number of people on Wednesday. Take away 12, giving us 46. So in essence, we can say on Wednesday we had 46 people. On Friday, the number was half of Saturday. Here we do not even know the number of people that was there on Saturday. And on Saturday, we don't know the number. But if we had the number of people on Saturday, we would find half of that number to be the number of people on Friday. And now that we do not have the number of people on Saturday, we can give it a value like X. So here we have now 1, 2, 3, 4, 5, 6 days. And then we are told the total number of people who visited the park for the 6 days was 374. Now, the best way to come up with the answer is to equate the total number of people from Monday to Saturday to this number that we are given as their total. So that through that way we can be able to find the unknown. So on Monday we have 65, 49 on Tuesday, 58 on Wednesday, and 46 on Thursday. On Friday, we shall have half of X because we don't know the number of people on Saturday. And then on Saturday, we shall have X. But the total number of people for the 6 days should give us 374. If we add all these numbers, in other words, now we have formed an algebraic expression, we can be able to put like terms together, where if we add all these numbers, we shall have 218. Then we shall have half X plus X. And here X is the same as 1X, so we shall have half X plus 1X being equal to 374 people. So 218 plus 1.5 X is equal to 374. If we take 218 to the other side of the equal signs, what happens in algebra is that we shall be left with 1.5 x on one side. Then we shall have 374 take away 218. If we subtract 218 from 374, we shall have 156. That is the same as 1.5 x. If we want to find the value of x, we shall divide both sides by 1.5, and then we also divide 156 by 1.5. The improper fraction of this is 3/2x. Then when we have a division sign, because we are dealing with fractions, we shall make it a multiplication sign. Then the improper fraction of 1.5 will be 3/2. Instead of using 3/2, we get the reciprocal, which shall give us 2/3 is equal to 156. We put it over 1 so that it can appear as a fraction. Then the reciprocal of the improper fraction of 1.5, which is times the reciprocal of the improper fraction of 1.5, which is 2/3. So 2 will cancel with 2, 3 and 3. We shall remain with x being equal to here 5 to 52 times 2 is 104. So meaning that x is 104. So back to our question, x was standing for Saturday, so we have 104. And because Friday depended on Saturday and it was half of what was on Saturday, so we shall have half times 104, giving us 52. So the people who attended the